Okay, so first, thank you for coming here at Kiln. We are delighted to having you, sorry. And yeah, we are going to talk about MEV Burn. And maybe just first question, more for Justin. Before going into MEV Burn, can you really briefly explain what is EIP 1559 and what is it related to, but very briefly, because we know that MEV Burn is kind of linked to EIP 1559, and maybe it could be worth to recall.
Throwback to 2021.
Okay, so the mental model that I have in my mind is that there's two use cases for block space. On the one hand, 99% of users want to use block space to include transactions on chain, to have them confirmed. And when there's competition for this inclusion, you have what's called congestion. And basically, EIP 1559, you can think of it as being an oracle for congestion. It kind of tells you what the price of congestion is. It's a pricing mechanism. And the reason why it was introduced is that this pricing mechanism is really, really useful for users, because now they know what to pay for when they want to use this congested blockchain. Before that, we had this first price auction where either you would underbid, and then you'd have to wait a very long time for your transaction to be included on chain, or you'd overbid and then you'd waste your ETH. Now, as a byproduct, as a second order effect of this pricing mechanism, we had some economic consequences from the burning of the ETH. And this has all sorts of macro benefits, yeah, I think what we'll talk about is the fact that MEV Burn is the complement to EIP 1559, because there's a second use case for block space, which is ordering. Some transactions really care about where they are within the block. And maybe the best part of the block is what's called the top-up block, where you can do all the arbitrage that has happened in the last 12 seconds. And it turns out that there's a mechanism called MEV Burn, which takes this value and will burn it, just like EIP 1559 did for congestion. And so now we have an oracle for MEV, which you can call an MEV oracle. And it also has the macroeconomic benefits for Ethereum as well.
Okay, cool. So 1559, with 1559, Ethereum has kind of an oracle on itself to estimate the base fee.
Right.
And it fixes the issue of congestion fee. And now with MEV Burn, it will be kind of the same stuff, but for contention fee, and we will burn exactly what?
So we burn the MEV. So it turns out that the benefits are not from a user experience standpoint, they're actually from a security standpoint. And one of the reasons, for example, is chain stability. Right now, we have proposers that are participating in the lottery. And if you're lucky enough to be chosen in the lottery, you're gonna get this what I call an MEV spike. And the reason I call it a spike is because it's extremely volatile and extremely spiky and unpredictable. And this has this is a force for pooling, for example. If you're a small validator, you're gonna get the median amount of MEV, which turns out to be roughly 3 times smaller than the average MEV. And so maybe you get extremely lucky and you win the jackpot in this lottery, and then you'll get much more than the average. But most validators will actually get below the average rewards. And so that's an incentive to pool. But there's other forms of second order negative externalities. One of them is around MEV stealing. Let's say that I'm a proposer, and I want to steal the MEV from the previous proposer. What am I going to do? I'm going to DDoS the previous proposer, so that's going to be an empty slot. And then I'm going to get double the amount of MEV, the MEV from the previous slot and from that of the next slot. But then you might try and do reorg attacks. You might try and do eclipse attacks at the networking level. There's all sorts of attacks. And for pools specifically, so if you look at Lido and Rocket Pool, you have this principal agent problem, where you have an ETH staker that provides the ETH to an operator who will operate the validators. And if the validators that are being operated receive a spike, which is greater than the amount of collateral that the operator has put forward. This could be reputational collateral in the case of Lido, or it could be financial collateral in the case of Rocket Pool, then it's actually the best move for them is to take the MEV spike for themselves instead of redistributing it to the ETH holders and foregoing the collateral. So there's this kind of incentive incompatibility with the way that decentralized staking pools are built today.
Okay, so right now, if you run a solo staker, solo validator, it's like if you buy a lottery ticket with almost everybody is a loser and a very few people has maybe 200 or maybe 300 ETH of MEV rewards.
Yes.
And that's why very often people say, okay, there is about 6% of APO on ETH, but I don't remember the number exactly, in average. But if you take one solo staker, it's like he has very lower APY. So the median is really lower than the average. Yeah.
Right.
That's cool.
And it also goes a bit to what Mike was speaking earlier, that if we're looking at if we're thinking about what validators, what kind of economics we want for them, MEV adds tons of stuff happening, sometimes it's high, and it adds all of that. And we're one of the things that MEV Burn would do would be if eventually a lot of it get burned, they do get some, they would keep because they're competing and they'll take the delta. But if we get rid out of a lot of that, I think from the protocol perspective, it's a lot easier to manage, okay, what would be the outcome? How many we want? How do we adjust it? And you don't have this joker wildcard there that would change stuff.
Right. As crypto economic designers, we want to set the incentives. And MEV is a distortion of the incentive that we set, and so it makes our life more difficult. When we remove MEV, we have more control over what we're designing, and we can achieve more robustness and more security.
So actually, we don't remove MEV, we remove some negative externalities of MEV by burning the...
Exactly, yes.
And if we burn, so it will drastically reduce the amount of ETH which is available on the network. Right now, I guess there is 120 million amount of ETH on the network, and sometimes, depending on the network usage, due to EIP 1599, it can go up and go down. And with MEV Burn, it will reduce more the amount of burn ETH, and so ETH will be more scarce than today.
Yes. So in the short term, I expect it would be a 500,000 ETH per year optimization.
500,000 ETH per year, and today is how much approximately?
So, I mean, right now we're going down something like, I don't know, someone help me, 300,000 ETH per year or something.
Yeah, I don't remember.
Can someone go on ultrasound?
But yeah, it might double or triple, the speed at which it goes down, and that changes the equilibrium because, so we had this period of growth, we peaked, and then we're going to go back down to a new equilibrium. Without MEV Burn, it's going to be here. With MEV Burn, it's going to be slightly lower.
Oh, that's cool. For its order. And I guess one of prerequisites of MEV Burn is to have ePBS, so enshrined PBS. And maybe, Stéphane, for example, can you explain briefly what PBS currently is? And after we'll be able to talk about ePBS more specifically.
Yeah. I'm curious, is it still ePBS? Is it compatible with Pepsi? Is it compatible with, does it still require single slot finality?
Doesn't require single slot finality, but is not compatible with Pepsi, would be my take.
Okay. PBS, proposer builder separation, the ability for validators to outsource block construction to a marketplace of block builders. In the current model of MEV Boost, intermediated through trusted counterparties called relayers, and they essentially compete for the right to sequence transactions on behalf of the validator. In the process, extract MEV, etc. One of the key benefits that's sort of relevant to this conversation of the introduction of PBS is just to put a price on block space. And as Justin mentioned, sort of this this principal agent problem that we sort of we have between stakers and staking node operators is that if the stakers don't know the value of the blocks, it's possible for the node operators to sort of secretly capture value. by just either side channel payments or extracting MEV themselves. And so having a public sort of track record of what the value of the block is super useful mechanism for being able to do any of this. That's PBS.
Okay, so that's PBS is what we have today. And so we call it PBS or out of protocol PBS. And what's the difference between PBS and enshrined PBS?
I think that's sort of still being figured out, exactly what enshrined PBS looks like. Thanks, Mike. But the idea is to sort of remove the relay rule.
Okay.
And put the rules of the auction for block space within the protocol itself, within the consensus rules, such that you don't have a trusted counterparty that's sort of involved in the intermediation of the auction.
Okay. I want to throw a bit of spice both to previously on MEV Burn and on PBS, that sometimes I have strong opinions on this and I chat with people on Twitter and they say, well, PBS is a good thing because it builds this entire thing and value is extracted, and instead of just going to the large actors, everybody could get the same, so it's good for decentralization. And MEV Burn, well, we take that and it's good for scarcity, etc. I do want to point out that the other side of it is that it maximizes MEV. It does not minimize it. We have the ecosystem in which everybody are trying to extract as much value as possible from DeFi users and DeFi LPs. And the fact that we take that amount and instead of Jump or Wintermute or SCP or any of the others, instead of that keeping it to themselves, instead go to the validators and the stakers, means squat for the DeFi users who are bleeding money. And if we take that money and we burn it, and so like it's scarcity, great. Still means squat for the DeFi users and the DeFi LPs who are being affected by it. Now it is going potentially, like it was when PBS came out, and kind of, okay, immediately at the beginning, well, validators took all the value. Now we have like, okay, the direction of order flow auction. Users are trying to take the other side and keep some of the value to themselves. Protocols, wallets, anybody in the middle trying to get a piece of that value, so which is potentially better for somebody to stay with the users. But it doesn't solve MEV. And that, like, it's kind of like it has, well, if we extract all of that, maybe it's better to burn it than to give it to some entity, and maybe it's better to give it to the validators rather than the traders, still screwing over all the DeFi users and LPs.
Okay.
I mean, there's two problems here that we need to solve. One is we need to minimize the generation of MEV in the first place. And then two is the extraction of the MEV. And PBS is not trying to solve for minimizing the production. It's all about the extraction side of things and making sure that the extraction retains the decentralization and doesn't diminish that. On the generation side of things, we have two classes of ideas. Like one is encrypted mempools, where we hide the content from these searchers so that they can't extract as efficiently. Or not at all. And then the other class of ideas, which is what you're working on, is to change the sequencing. For example, have some sort of first come, first serve type of sequencing. And I think what will happen is that in the end game, there won't be any toxic MEV, meaning there won't be an MEV where there is a clear user that is a victim. Instead, we will be left with latent MEV that's just there because of market inefficiencies, things like arbitrage. And actually, that's healthy MEV because it kind of helps the prices adjust. So all the toxic stuff will go away through encrypted mempools and new forms of sequencing, and then we'll keep the decentralization and have the most valuable blocks go on chain with enshrined PBS and MEV Burn.
So do you agree that, or I say to people, no, it maximizes, like you're not representing Flashbot in any way, but the Flashbot vision, okay, minimize the MEV and distribute what we can to minimize. I don't see other people who say, like, this maxes the MEV except me. So, like,
I think interestingly enough, I don't think Flashbot says they minimize MEV. I think they mitigate the externalities of it.
oh, I have a screenshot of Bird saying, like repeat after me, minimize MEV, distribute what we can.
Okay. No, PBS.
Store on my computer for a future delete one.
Does PBS change the amount of extraction that happens? I mean, in some ways, yes. It makes certain types of MEV extraction easier to take place. There's the amount of MEV that gets exposed. Actually, if you look at like a numerical amount of like as a percentage of like validator revenue, probably the biggest contributor is like long block times. And so if you actually like speed up block times, you would actually be able to reduce the amount of like arbitrage opportunities, which is the biggest contributor to block space value right now. Now, does that mean that like that's the right direction to go into? Like probably not. What does PBS do? I mean, it basically says for a 12-second block, you can have essentially the full 12-second of preparation for MEV bots to be able to maximize the amount of MEV that's extracted in this time. So PBS does like fully extract MEV. Does it maximize it or minimize it? I don't know. It depends on your perspective of.
I would say even somewhat giving counter to my previous, but it feels like a trade-off, right? It's kind of like we could have big validators and small validators. Big validators are killers, they're tagging extract because they have an MEV team in-house and they extract more value, and little ones, so it's not fair to cause centralization. Or we could make them all killers. So they're all kind of like have like special forces, like people working, etc. So which one is better? The one where some of them are kind of like super good at it, or where everybody is and it's more? And
I think it
feels like a bit of a trade-off between the two.
I think the interesting thing here is like this is like an assumption that we've had that like MEV would lead to validator centralization, but I don't know that that's necessarily true. Like I think stakers are sticky with validators and validator service like staking providers in a way that aren't necessarily that elastic to the yield that the service provider provides. And so the incentive to do MEV activity as a node operator is actually potentially much lower than we would have like normally expected. So like in the counterfactual world of like no PBS, would there actually be like an increasing amount of concentration? Like there would certainly be incentive, but there's also incentive within like a 1559 context for like validators to collude to like keep base fee down, right? So the question is like, is the incentive enough to actually have a meaningful impact on the behavior in the network? And I'm not convinced that it actually would have.
I actually saw the guy from Obel who was presenting at EthCC 2 days ago, and he said something that I didn't know. So he was kind of like looking at how much people have stake. And so like the average person has $600 or something like that at stake. They put it somewhere. It doesn't make sense for them to move it anywhere because the cost of making a transaction. So they put it with a staking provider and they keep it there, and it's super sticky. So I wasn't aware of it, but that might have something to do with that like they won't move to the highest deal because each one individually is pretty small. So I don't know, that was news for me.
Yeah, I don't run a node operator.
You don't run a node?
And so I don't know what are the market dynamics there. But my understanding is you're selling trust, you're not selling yield. You're selling large stakers, and I'm thinking of like, wealth management firms and whatnot. They're going to spread their stake across multiple operators regardless of the yield that the individual operator provides.
We should ask Kiln.
Is that true?
No.
And so I think, like individual node operators, like maximizing for the amount of yield that they have is not the only factor of the equation.
That's good.
Okay, thank you for your answers. And I have another question about ePBS currently. So with PBS or Flashbot auctions, both builders and both validators have to trust relayers. So they need to trust it. Does ePBS going to remove this need of trust? And how?
Right. So the answer is yes in the default case, but there is an edge case. So with enshrined PBS, really what you're doing is you want to try and guarantee the payment without having to trust anyone other than Ethereum, other than the beacon chain. And right now we're trusting validators. Now, in order to remove this trust and have a guaranteed payment, we need the builders to have collateral. So they post collateral on chain.
Some ETH?
Some ETH.
Okay.
And whenever the block value is lower than the collateral, then all is good. But what happens when the block value is greater than the amount of collateral? Then what I think will happen is that in order for the proposers to have this guaranteed payment, they're going to fall back to the relays to simulate the blocks and have a look and basically confirm that there is a payment within the block itself. So yes, for 99% of cases, I think relays won't be needed, but for this one edge case where the block value is greater than the amount of collateral, we will need the relays. The good news is that MEV Burn fixes that.
Okay.
So MEV Burn removes the need for relays, and the reason is that now the proposers, they don't care about this guaranteed payment because they don't get paid, they don't receive the MEV. And so they can just use this enshrined protocol without having to fall back to the relays in this edge case.
Okay.
And in the MEV burn, is it that if each, like you have different options from different block builders, and the proposer, the validator, would receive the delta between the best offer and the one after that? Like how much is getting burned and how much does it receive after the burn, if any?
Right.
Or does it all get burned because it's like based on what everybody agreed was the highest amount?
So in an ideal world, everyone could agree on what is the top bid and we'd burn all of it. Unfortunately, the best we can do is come up with a lower bound on what people agreed was the top bid 2 seconds ago. And the reason there's this kind of 2-second error term is because it takes time for information to travel in the network. And really, for the MEV burn to be a safe mechanism for the proposers, we need this property that bids will be gossiped throughout the whole network and be received by proposers and attesters within a period of time. And 2 seconds is just a number that was picked, which seems to be extremely conservative.
But can blocks be built more valuable after
Yes.
that? Because a lot of the value goes into the block literally at the last moment of the block. Mm-hmm. Because that's when CeFi DeFi arbitrage really come into play, when the CeFi DeFi arbitrage already know, okay, what's the latest state, what's going to be the prices, and then they make their bids.
Right. So it will be a partial burn where only the MEV that comes from the first 10 seconds is burnt, and anything that comes in the last 2 seconds is not burnt. If we naively assume that we have MEV growing linearly within a slot, then we'd be burning 5/6, which is 10 divided by 12. But if there's these weird things happening where SexDex only happens within the last few milliseconds, then that would not be captured by MEV burn.
Is there even an incentive for arbitrageurs to try to do it at the last moment to avoid the burn? Like, I don't know. I didn't think about it. Like,
so from the perspective of the builder, there's no change in the incentives. What you're talking about is, the best builder is able to capture the delta between it and the second best builder. That will still remain the same. The only thing that changes is on the recipient side of things for the MEV. Instead of the proposer receiving the MEV, it's the ETH holders that are receiving the MEV. But from the perspective of the builder, there's no change of incentives.
Throwing a malicious design into the air pays into a smart contract that pays half to the validator, half to the builder, so yeah, like half to the validator, half to the builder, and then trying to get some of that money back, or like.
Okay, great question. Great question. So
I don't know. I didn't think about it in advance. It was coming.
Yeah. So what about collusion? And it's a valid question to ask. Can the builders and the proposer collude to basically remove the MEV burn? And the answer is yes. But let me explain that it's actually not a big deal. Now, it turns out that it's strictly simpler for the builders to collude within themselves than it is for the builders and the proposer to collude, because there's one less party. Now, let's assume that the builders can collude with each other. If they can, then they would collude today. And the reason is that they would be in a power to keep all the MEV for themselves and give none of it to the proposers, which they are doing. But empirically, we can see that the builders are not colluding because MEV does flow to the validators. And so we should assume that if they're not colluding today, they probably won't be colluding after MEV burn.
Sometimes all you need for collusion is a good Schelling point.
That's a good point.
That's what you usually need. Like, colluding is a problem of synchronization. Like, if I trustlessly create a smart contract, really, like, and won't the proposer choose the one that pays? Again, smart contract, it pays like half and half, the additional MEV that doesn't get burned. Won't it choose such a block that pays to the smart contract that amount? Or something along these lines?
I mean, if the proposer sets up all sorts of fancy infrastructure for it to collude with the builders, then the builders can just replicate the exact same infrastructure and just remove the proposer from the equation. So really, it's about the builders. And to be fair, I am a little surprised that the builders today are not colluding and are willfully giving 1,000 ETH of MEV per day to the proposers. Like, what are they doing? They should be colluding.
I'm taking notes.
Yeah, me too.
Should we call Evgeny and ask?
Interesting proposition. Okay. We'll talk less after.
I'm already making a call. Right?
Yeah. And yeah, another question. So here at Kiln, we are block proposers and validators. And a big part of our API is MEV. And so with MEV Burn, we won't have MEV. A big part will be Burn. And so I guess it will decrease more or less for a lot our API. And can you confirm that? Can you confirm that it will not?
Can we delay that by another year?
Maybe for 10 or 20 years. Can you confirm?
Have you heard what happened to miners?
Who?
Proof of work miners.
I know. And yes, and how can we be sure that it won't disincentivize validators to put 32 ETH into stake and to run a validator? Because now it's quite interesting. If you burn the MEV, it will be less interesting and it will reduce the number of validators. I'm not talking about the max effective balance stuff, but it will reduce the number of validators on the network. It will, of course, increase a little bit the API on the consensus layer. But in overall, it may unsecure a little bit the whole consensus because we won't have as much as validators as we have today. And yes, isn't MEV Burn so not so good for the security of the network because of that?
OK, so let me address the second point on security. We've tried to design Ethereum so that if there's 0 MEV, the proof-of-stake system is still secure. Okay. And so from that perspective, any amount of non-zero MEV is wastefully paying for security. And this has consequences in terms of the scarcity of ETH, because there's more ETH that's being issued. But it also has consequences for the distribution between what I call economic security, which is staked ETH, and economic bandwidth, which was non-staked ETH, which could be used as collateral somewhere else, for example, in DeFi. Mm-hmm. And for Ethereum to be successful, I believe that we need trillions, if not tens of trillions, of trustless, decentralized stablecoins that are backed by ETH, the pristine collateral. And so if staked ETH kind of sucks up all the liquidity, then we won't be able to have these tens of trillions of dollars of decentralized stablecoins. So I think it is good to have a predictable and reasonable amount of staked ETH, and then for the application layer to be able to flourish and have lots of economic bandwidth to play with. Now, on the point of MEV Burn lowering the APR, I think this is wrong, and I think it's the exact opposite. But okay. I need to actually explain.
Interesting.
I need to explain what's going on. So the basic argument is that there is a cost of money. Let's say that the opportunity cost of holding ETH is 3%. Then we should expect that the validator rewards will tend towards this 3%. Now, if there's MEV Burn, or if there's not MEV Burn, in both cases, we will end up with 3%. Mm-hmm. And so what I expect will happen when we do, if and when we do turn on MEV Burn, is that yes, the API will temporarily go down, but then it will rise up to go back to the cost of money as the number of validators goes down. Okay, so from an ETH-denominated standpoint, the validator return should just match the cost of money and should not go up or down if we have MEV Burn or we don't have. Now, why is it a good thing? I'm just claiming that it will stay the same, but actually I think it will improve. And there's 3 reasons. Reason number 1 is that if you're a solo staker, for you it's good because your rewards go from the median amount of MEV to the average amount of MEV, okay. which is higher. A second reason is around taxes, which is a bit of a weird thing to say, but if you imagine a company that has profits, there's two main ways to distribute profits to shareholders. Way number one is dividends, and another way is with buybacks, share buybacks. And it turns out that it's more tax efficient in most jurisdictions to do share buybacks. And this is exactly what MEV Burn is all about. It's about buying shares, ETH, and then buying them back and removing them from the circulation. And you end up paying capital gains tax as opposed to paying income tax, which you would pay on your MEV. And so from the perspective of a staker, you're significantly increasing your APR. So right now, I'm earning 6% on my one validator that I'm running. Half of it goes to the UK government. So my net APR is 3%. But if I were to make 6% from, from capital gains and from the net ETH growth, then I'd be paying significantly less.
Interesting.
So, quick question: is MEV Burn existing because you're living in the UK?
I mean, my understanding is that in most jurisdictions, income tax is greater than capital gains tax. And then there's another reason why it's beneficial. Oh yeah, of course, which is that it is good for scarcity. It's a 500,000 ETH per year optimization. And so from a USD denominated standpoint, it's a no-brainer. And if you look at stakers, for the most part, they're ETH holders, right? They have 32 ETH. And so it's good for them for the USD denominated value to go up. So yeah, just to summarize, the ETH denominated returns should stay the same around the cost of money, but the USD denominated return should go up. And then there's less of sell pressure on the back end with taxes. And then there's less volatility, which means that from the perspective of a solo validator, you're net up. Yeah, you're net up.
OK, that's clear. It's quite counterintuitive.
It's very counterintuitive.
Yeah. Maybe there is time for a few questions for the audience.
Do you buy it? Do you think it's good for Kiln, his business?
We will have a talk if you want with both of us after.
Doesn't it also just affect as if this would also trend that way? It would just like take 5 years or so many more validators join the set, and it will go to that APY anyway. It will just go that way after we reach like 5 million validators, which should be the same thing. You'd reach it anyway.
It's just you will have half as many clients, but don't mind that, do you?
No, yeah, we prefer to have less clients actually.
That's what I thought. Yeah,
no, because I'm personally managing the infrastructure at Kiln, and it's a pain to have so many beacon nodes and so many validators clients.
I mean, it is a fair question for operators like Kiln and projects like Lido. There will be a shrinkage of the total number of validators, total number of staked ETH. And so you need to ask yourself, okay, is the shrinkage going to be compensated by other things like the price of ETH going up? And I can't say for sure, but if we reduce, for example, by 30% the total size of staked ETH, but we're making the ETH supply go down by 500,000 per year faster, then maybe the price of ETH might go up more than 30% and actually compensate for this reduction.
But that depends on Dogecoin.
Okay, that's fine.
Also, the validators, their costs aren't denominated in ETH, and so.
Right, costs are denominated in US dollars, which I guess is a good thing if the price of ETH goes up, because it means your net returns from an APR standpoint go up.
No, but the margin that they're being compressed on their customers is not on an ETH denomination; it's on USD denomination.
Right.
Which means that even if the price of ETH goes up significantly, the revenues that the node operators are generating aren't necessarily going up in match with it.
Is that true though? I mean, for example, Coinbase just charges 25% flat on. It's denominated in ETH.
That jealousy?
I don't know. Okay, maybe it's the fact that they're just charging ETH and they are tied to it, but it doesn't seem like an equilibrium.
Maybe.
Today.
Maybe.
Is there any question? Okay.
Yeah. It's about the collusion part of the validator builder part. And I think I got a missing piece of the puzzle for this. is like, I agree that it's easier for builders to collude than for builders and validators. That makes sense. But I also agree that if most of the MEV being extracted is CeFi DeFi arbitrage, it is true that most of the valuable bids will happen late in the block, which is like in the last 2 seconds maybe. And then I don't think it changes the incentives compared to today, but it doesn't make an improvement either. If most of the value is actually bids that happen in the last 2 seconds, then it just doesn't really make sense to go all through all the changes and implement MEV Burn if
you're saying it would make a smaller impact. Why not enough? Like, do we know what's enough?
So, well, it depends, but like, let's say we go through all the trouble of implementing MEV Burn, and let's say 80% of the value is actually happening in the last 2 seconds because of CeFi arbitrage, and this it's not driven by a need or want to collude. It's just like, by definition, a CeFi DeFi arbitrager kind of wants to wait as long as possible, because otherwise he takes the risk of holding the assets and the price might move. So I was wondering how you think about this.
So we recently hired Tony at DeFi Foundation. He's great with data. He's the one behind MEVBoost.pix and tornadowarning.info. And he actually looked at exactly this question. He basically looked at the top bid 2 seconds before the end of the slot, and the top bid, at the end of the slot, and he graphed it. And just looking at it visually, it didn't look like a disproportionate amount of it was in the last 2 seconds, but to be confirmed and to be looked at for sure.
There's a cool good.
So we did some research on this. Like, what is the incremental amount of value? And we worked with the ultrasound guys on it. The incremental of value per sort of millisecond intra-block. And if you think about, like, where does the value come from? It comes from, like, price movements on Binance, right, most of the time. Or you could call it, like, entropy into the world, like whether it's like a new user that, like, clicks a trade on Uniswap that creates, like, a sandwich opportunity or something. Those are uniformly distributed throughout a block. And so the origin of the MEV follows sort of a uniform distribution throughout the block, even though the bidding strategy for builders is different. Like, they increase the amount of bids at the end of the block because there's just no reason for them to do bidding at the beginning. They are exposing information about their, like, willingness to pay for the block space that other block builders can use against them in this, like, auction model. And so it's actually, like, the fact that you have more bidding towards the end of a slot window is not because of there being, like, more MEV opportunity there. It's just, like, a pattern of the bidding strategy for PBS and block builders.
Okay. Thanks for the question. Maybe a last one or last one. A short one, please.
Yeah, I just want to ask, like, why distribute the value to ETH holders instead of, like, users of DeFi applications who are actually getting sandwiched, whatever? Yeah.
Or just flatten it across the entire validator set instead of distributing it to all ETH holders. Right. It's like another question. I remember there was a question with, like, 1559 as well, like, why do we burn it instead of distribute it to all the miners in, like, a uniform way? And I don't know, I never got, like, a convincing answer for that. In terms of, like, why not distribute it to DeFi users, I think what Justin said there is true, which is, like, it's not up to the protocol to, like, fix the things at the application layer. Like, I think there's, like, things that you can do at the protocol design layer that make it easier to build, like, better applications that, like, do better price discovery, for example. Like, I think a FIFO-based sequencing model with, like, faster state updates, like block speeds, is just naturally better for building price discovery mechanisms like exchanges.
Instant inclusions.
It's just naturally better. And so what does that mean? I mean, it means on one hand, it's likely that over time, more and more of the DeFi activity is just naturally going to migrate to platforms that support that kind of sequencing model, which is a good thing. Like, layer 2s exist for, like, that reason, essentially, right? And they provide good properties there. So naturally, I think the incentives are already for users to migrate their activity to where they are not getting, they're getting a better deal. The other thing is, like, just application design, right? Like, LVR and sandwiching exists because of Uniswap and the way that Uniswap is designed. Now they're starting to take it more seriously and like deploy solutions that help mitigate some of those value leakages to downstream in the stack. As those get more adopted, we will see less and less of that value being exposed to validators. Is it the perfect solution? Like, no, it comes on with like additional trade-offs. Like now all of a sudden you have these more complex systems that do sort of mitigation of MEV using like off-chain components. And so you have concerns over censorship, you have concerns over centralization of order flow and whatnot. And so it introduces other concerns, but it does reduce the amount of MEV that ends up flowing down to the validators.
One more point on that, which I've learned along the way, is also that the Ethereum Foundation and the core devs, when making these decisions, the goal isn't to improve application or user. The first priority before anything else is what's good for the chain. Let's make it secure. Everything else could be figured on top of it. This comes first. So it's kind of like self-preservation to an extent. So if this affects like the economic incentives, the number of validation, all of that, like this takes priority in the perspective of the people building it. And I don't necessarily agree, but that's kind of like, this is the politics or agenda or spirit or however you want to call it, that it's kind of like this comes first. And so the decisions are made, what would make the chain better and more secure and efficient. That comes first before what would be better for the user.
Okay. You say that a secure chain is good for the user?
That's implicit. I'm not saying it's bad. Like, obviously, it's not to say that it's a bad thing. It is to say, like, this comes first, this is the first priority. And so, no, not figuring out how to give it to the end user. Let the DApp and the user figure it out. We make the chain better. That's the spirit that I'm always getting, which is reasonable.
But actually, the design choice of sending the ETH to the holders as opposed to the validators is specifically with users in mind. And the reason is that if we give it to the stakers, during a bull run where MEV has gone crazy, all the ETH will be staking, and there'll be very little left for the users, for example, powering stablecoins.
Okay, so stability of the chain first. Thank you.
Ask Mike.
Okay. We have to wrap up. Thank you very much.
Bye, everyone.
Lot of news to be here.